Okay, guys, so here's the Unit 3 test review. Which type of symmetry does number 1 have? Well, it looks like I could rotate it and have it look exactly the same, but I can't specifically see any lines that I could draw through it and have it fold back on itself. So object A just has rotational symmetry. Alright, number 2. A graphic artist was painting a logo in the shape of a convex regular polygon. Regular polygons, really the key words here. And she measured one of the central angles to be 72 degrees, which means basically if I had a shape, any shape it happened to be, from the center out to 2 consecutive vertices was 72 degrees. And we want to know what the name of the polygon was, which basically means we need to know the n, number of sides. Okay, so we actually had a formula for this. We learned that the central angle was equal to 360 over n, the number of sides. So we know that 72 equals 360 divided by n. We're going to learn a lot of rules of proportions about how to really understand how to solve this. Basically, it's like we're multiplying both sides by n. So we get 72n equals 360, and dividing both sides by 72. This gives us n equals 5. If something has 5 sides, then we call it a pentagon. So there you go. Alright, the figure below, how many axes of symmetry are there? At first look, I almost said none, and I still kind of think that. It's very subjective, and I won't give you anything as subjective. However, the more I look at it, I think that there's actually an axis of symmetry right about there, perhaps, which you could fold it over. So, honestly, for this question, I guess I would take one or none, kind of depending on what you think. As I said, nothing so subjective on the test tomorrow. Alright, from section 3.2, we want to know which of these descriptions does not guarantee that it is a rhombus. So here we're really asking ourselves, what are the characteristics of rhombuses? And which one of these is not a characteristic of rhombuses? So basically, we had learned a lot of stuff about a lot of characteristics about all the quadrilaterals. Specifically, a rhombus has congruent sides. It has perpendicular diagonals. It has diagonals that bisect the angles. And that's pretty much it that's specific to a rhombus. So let's look over here. Quadrilateral with diagonals that bisect the angles. Oh, that's a rhombus, so we're going to cross that out because we want not a rhombus. Or not guaranteed that it's a rhombus. A parallelogram that has adjacent sides congruent. All the sides are congruent in a rhombus, so that's specific to rhombus. Parallelogram with perpendicular diagonals, once again, specific to a rhombus. And so therefore a parallelogram with opposite angles congruent. That's true of all parallelograms, so it's not specific to a rhombus. Alright, question number 5. Select the geometric figure that possesses all of the following characteristics. It's a quadrilateral. It has diagonals that are congruent. Okay, let's talk about that. We learned that diagonals were congruent in rectangles. So any type of rectangle, the diagonals are congruent. And opposite sides are parallel. That is true of all parallelograms. But the only thing that has all of the following characteristics, not a parallelogram, because it doesn't have the diagonals that are equal. Not a rhombus, for the same reason. Rectangle, yes. Trapezoid, no. So the answer is C, rectangle. Alright, number 6. All angles and sides of a certain parallelogram are equal. Which of the following best describes the parallelogram? So let's draw a parallelogram. All of the angles are equal. So my diagram doesn't really do this justice. And all of the sides are congruent. All the angles are congruent makes it a rectangle. All the sides congruent makes it a rhombus. And the only one that has both of those properties is a square. It's the child of the rhombus, the rectangle.